You're here, you made it to the practice final. Let's do it and get you prepared to wrap this class up. The practice final is worth 20 points. Complete it by hand and turn it in as one document to earn all of these points, just like you do for any practice test. Practice final is 18 questions, just like the actual final. And of course, it has similar questions to the actual final, meaning this is not just going to give you points for completion, but it is your number one study guide that you can use while you take the final. It's open book, open notes. Okay, and make sure you study your best and take your time because you only have one attempt. And if you feel like, hey, you need to take a break, you want to study more, that's perfectly fine. You don't have to complete it all in one sitting. Every student is required to take the final, regardless of your current grade. And during the last week of the school year, these are the important deadlines to pay attention to. They will also be in the class announcement, but here it is. During the last week of the school year, that changes depending on the year you're watching this. The final will open Tuesday at 12 p.m. and is due Thursday at 4 p.m. But you have until the very last day of school to turn it in, which is Friday at 4 p.m. So why is it due the day before the last day? Well, it's as a reminder, okay? If you don't take the final by the due date of Thursday at 4 p.m., all of a sudden your grade will zero out of 90, and that will be your grade until you take the final, okay? So you will know at that point what your grade will be if you don't take it. And at that point, you can also calculate how many points you need to finish the class with a certain grade. Whether you want an A, a B, or a C, you can figure that out. If you need help calculating that, I'm sure you can look it up on AI or Google or YouTube, or you can, of course, always ask me. The final is 18 questions. Questions are 5 points each, making it a total of 90 points. And like any other CGA, if you feel you deserve some points and the computer gave you no points, email me and I can look at your test to determine if you do deserve those points. Just really commenting and stressing, turning in the final on time because things come up in life, right? Plan to take the final early since it can't be taken after the last day of school, Friday at 4 p.m. If it's not completed and submitted at that time, my hands are tied. You're going to receive a 0 and your grade in this class will be dropped by 90 points. That's pretty significant. And that will be your final grade in the class. So, to recap those important end of year deadlines, during the last week of the school year, all TGAs are due on Tuesday at 4 p.m. because teachers need time to grade all of that work that gets turned in and get your report cards out to you before we're off for summer. And then all CGAs are due Friday, the very last day of the school year at 4 p.m. So keep in mind, when I'm saying due here, that's when it closes. When I'm saying due here, that's when it closes. These are the very last dates. So if you see a due date on a CGA, like this final will be, that's going to be on Thursday, but it's closing. It's finally due on that Friday. Make sure you submit by the deadlines because late assignments will not be accepted. On to the math. We have 18 questions. We're going to do 5 each day and then 3 on the last day, totaling to 4 days, starting with number 1. What characteristic is correct of the function we see? You should be providing some type of explanation as well as an answer. And you should be pausing this as we go to test yourself because this is all review. Okay, well, this is an odd function, but why? It's all about the exponents, right? If the exponents are all odd, which they are here, notice if you don't see an exponent, it's an invisible one, right? So if all exponents are odd, it's odd. All exponents even, it's even. If it's a combination, it's neither. So if you had odd and even exponents, that is neither, okay? Because it's an all or nothing situation. And what about a number, a regular constant number like 3? Well, that's going to be even because you could think of it as 3x to the 0 power. And that's number 1. Make sure you write the explanations. Number 2, solve the system of equations. Give it a try. Hopefully you read the clue on the board to help you get started. Since y is equal to y, then this is equal to this, right? That's the definition of equality. So ultimately, we can set this equal to this and then work it out from there. So that's exactly what I do. Set them equal to each other. I know I have the highest power of x being a 2, so I'm thinking zero product property will help me factor this. So I move everything to the side with x squared. But then I notice I don't even need to factor because this is such a simple polynomial. If there was an x here or the leading coefficient was something else, maybe I'd need to factor. Okay, but in this case, I do not need to. I can just isolate x squared by adding the 1 to both sides and then use the inverse operation of square rooting. Don't forget that always includes a plus or minus to isolate x. So we get x is equal to positive and negative 1. So how many solutions will there be? 2, right? If there's 2x values, there's got to be 2y values that go with them. How do we find them? We substitute into either equation because remember, a solution to a system means it makes both equations true, right? So I don't know about you, but I would pick this simpler looking equation to substitute into, and that's exactly what I do. Substitute in 1. So when x is 1, y is 0, there's one solution, and then negative 1. When x is negative 1, we get y is negative 4, 2 solutions, which are points where they would intersect on a graph, but we weren't asked to graph here. But we are now. We have 2 quadratics. Notice one's positive, one's negative. Here are the steps to solve. Remember, these are both parabolas. And this is the formula you need to really help you start graphing. Because yes, you could just plug in different x values and find y values and do a bunch of work and find a bunch of points. But finding the vertex is really going to speed up the process. Okay, so the first thing to do is take your first function and use that formula to find the x value of the vertex. Remember, b is the coefficient of the x term, in this case 2, so b goes up top, and a is the coefficient of the x squared term. We don't see anything, so it's 1, always. We know this. So we multiply and divide, we get negative 1. That's the x value of the vertex. And since it's the vertex for this f of x function, we have to plug it back into this f of x function, and that's exactly what I do. Plug in negative 1, square it, multiply it, subtract, we get negative 3. So the vertex is at negative 1, negative 3. We see it right there. Now, when it comes to finding other points, we're going to just have to pick some x values, but don't forget the axis of symmetry. That is going to save you some work. So I would just go ahead and pick any x value on the left or the right. I typically choose to go to the right. And you could pick 0 or 1, something like that. Can't pick -1 because this is on -1. So what if I pick 0? Well, I plug in 0 as you see here, and this all becomes 0, so I'm left with -2. So when x is 0, y is -2, boom, there's a point. And the axis of symmetry comes in handy because if there is a point up 1 over 1, there's also a point up 1, left 1. Sorry, I should have said up, if there's a point up 1, right 1, there is also a point up 1, left 1, because the axis of symmetry acts as a mirror. So that saves us the time and the energy of doing this work here. We don't actually need to do the work for that other point. So one line is graphed, f of x. Now we need to do g of x. Very similar, it's a quadratic, but it's negative and there's no x value. No big deal. We go about it the same exact way. Use this formula again to find the vertex. And if you feel like, man, this formula makes my life harder, it really doesn't. Plugging in countless x values and finding points that way takes much, much more work. Very tedious process. We're looking at g of x now. So let's see. We plug in b and a into this formula. X value of the vertex is 0. Plug back into the g of x function to find the y value is 2. There's our vertex. There it is on the graph. Okay. Now, again, same idea. Axis of symmetry goes right through the middle. And this is where we need to really apply ourselves and think about what's going on. Okay? Because at this point, let's imagine it together. You have the red line, then you have your vertex, but we don't know where the rest of this blue line is yet based on the work we've done so far. So I would pick an x value of 1. That's the next value over here, right? And fortunately, that works out. That not only gives me a point on my blue line, but it gives me a solution to the system, which is what it's asking, right? If you see this notation, what are the solutions where f of x equals g of x? It's asking what are the solutions to the system. Okay, so at this point, great. We would know that this line goes down like this, but we don't quite yet know what's going on the left. We know based off the axis of symmetry, there's a point right there. So we know it's heading in this direction, but where is it going to intersect the red line? Well, I would pick whole numbers and look, whole number 1 is there. -1. The next whole number there is -2. So I would plug in -2. So let's do that. Let's plug in -2 and see what happens. We get -4 plus 2. Well, -4 plus 2 is -2. So, eureka, there's another point at -2 too, and that is another solution. Remember, solutions to the system are where the two lines touch. So there it is. Number 3, and now we're on to number 4. The table of values represents function g of x, and the graph shows function f of x. Which statement is true? Try to go through all of these and explain why or why not each one is. That really will give you a solid understanding of everything that's happening. Let's see how you did. The x-intercepts, so we're looking for true statements, right? The x-intercepts of f of x, so right here and here, that's very easy to see for f of x, are common to those of g of x. So they're asking, are they the same? That's what they mean by common. The x-intercepts of f of x, we found them visually. But what are the y values for x-intercepts? They are always where y is 0. So we're looking at our table now. Don't forget that g of x is the same as y. So when y is 0, x is -1. When y is 0, x is 1. Is that the same as our graph? -1, 0 and 1, 0? No, that's g of x. F of x is here and here. Those are not in the same place. B, f of x and g of x have the same y-intercept. Well, that's exactly the opposite, where x is 0. So here, that's going to be 1. And where is x 0 in our table? That's 1. So we have -1 here, +1 there, not the same. False. C, the minimum value of f of x is less than the minimum value of g of x. Minimum means lowest y value. Okay? So lowest y value, let's take a look. Here it's -2. So that's for f of x, it's -2. And for g of x, it's what? Lowest y value is -3. So g of x is lower than f of x, making this false. And finally, we find our true statement, f of 1 less than g of 1. Well, that's basically saying when x is 1, what is y? So look at our graph, f of x. When x is 1, y is -2. That's our vertex. We found it, right? So f of 1 is -2. And g of 1, well, that's where x is 1. G of 1 is 0. And clearly, -2 is less than 0. So that's a true statement. And our last question for now. Write this in simplified radical form. And I can't stress this enough. Since you're being asked to write this in simplified radical form, don't just plug this into your calculator. This is not a question asking, do you know how to use your calculator? It's asking, do you know the rules of radicals? Hopefully you found the answer to be C. Okay, the first thing you need to do is convert from this exponential form to this radical form. And how do we do that? Well, I have a little saying, you've heard it before. Dive in, no problem. Where does this saying come from? Well, it's because the denominator, let's color coordinate a little bit. The denominator becomes the index and the numerator becomes the power. Notice the base stays the same and it's under the radical sign. And we've successfully converted now from exponential to radical form, but we're not done. Okay, here, no, these are the same thing. That little 2 index there is the same as not showing it at all because it's called a square root, right? If you don't see anything, it's an invisible 2. So at this point, we need to see if it can be simplified. And if you think back, if you remember when we learned this before, the rule is if the power is bigger than the index, there is simplification that needs to happen. If the power is bigger than the index, we must simplify. Okay, so you need to keep that in mind as well as the rules of radicals, which are if you're multiplying with the same base, you add the power. Okay, so what we're doing is we're asking ourselves, how many times can I write 7 squared where the exponents will add up to 5? So this little index guy is, guys, is powerful, right? Small but mighty. It's the gatekeeper, right? If the index matches the power, then 1 gets to run free. These cancel each other out, right? Squaring and square root are inverse operations. So if we write 7 squared once, that's totally fine because we're not to 5 yet. Can we write 7 squared a second time? Yes, because 2 plus 2 is 4. And then what do we add with 45? Oh, 1. That's why we write 7 to the first in the end. Okay. So ultimately, this is another way of writing this. We're just breaking it up. And why do we break it up? So we can see clearly what needs to come out. 7 gets to come out, 7 gets to come out, and whatever comes out multiplies. So we're left with 49 square root 7. And that's the first segment of our final review. Come back to get the rest.